to continue talking about the process of filtration, how blood is filtered, and the formation of urine by the kidney inside the nephrons. Yesterday we talked about cortex, medulla, lobe of Henle, collecting duct, glomerulus, and Bowman's capsule. Just we identify them and we identify their locations. But now, inshallah, we are going to talk about how each one works and the role of each. Now, as blood comes from the renal artery, it comes at high pressure as it is carried by an artery. As we know that arteries carry blood at high pressure. So the blood comes to the glomerulus at high pressure. Glomerulus, as we said, it is a tangle of blood vessels. I mean that these blood vessels are folded over each other. Okay, so when the blood comes to them, the blood is not distributed and the blood pressure doesn't decrease. The blood pressure increases. So here we have high blood pressure inside the glomerulus. The blood is squeezed inside this glomerulus. And then what happens? The materials inside the blood go out according to their concentration gradient. They go out of the glomerulus to the Bowman's capsule, then to the nephrons. Okay, so what goes out? Water goes out, is squeezed out and goes from glomerulus to the Bowman's capsule, as water is higher here than in the nephron, so it goes down its concentration gradient. Salts also go out of the glomerulus to the nephrons. Glucose goes out. Urea goes out. So here, what is collected now? We have urea, salts, and water, glucose, and urea. All of these materials is squeezed out of the blood to the nephron. Now, what happens next? Once they go to the lobe of Henle, here we have reabsorption. Not all of these materials are excreted as urine. Then we would get dehydrated. If all of the water goes out, would go in the urine, then we got dehydrated. Also, the glucose, not all of the glucose go out, not all of the salt go out in the urine. So 99% of the water in the glomerulus goes to the nephrons. If it goes out as a urine, we get dehydrated. That's why most of water should be reabsorbed back to the blood, and some salts and 100% of glucose should get back to the blood. As you noticed here, proteins don't go out. Proteins are large molecules. They do not go out from blood to the nephrons. Anyone gets protein in his or her test, that means that there is something wrong with the kidney function. So here, what goes back? Here we have reabsorption. As we said, most reabsorption takes place in the lobe of Henle. So what gets reabsorbed here? All glucose. All glucose is reabsorbed at the lobe of Henle. All glucose is reabsorbed. What else? Some salts. What else? Most of water, because high amount of water is squeezed out of the glomerulus to the nephron, so we should get it back. So these materials are reabsorbed back to the blood. So here in the glomerulus we have filtration, because the materials go out. Here at the lobe of Henle, we have reabsorption back to the blood. Now, some salt, some water, no glucose. Listen, urea, salt, water, urea, continue the path where to the collecting tubule here, or to the collecting duct. So here we have urine. Little bit of water, little bit of salt may be reabsorbed, continue reabsorbing here back to the blood, but very little amount. So here eventually we have urine formed. We have urine. Urine is made up of what? Is made up of salts, water, and urea only. No glucose, no proteins. So you have to know these processes, filtration and reabsorption, what is being filtered and what is being reabsorbed back, and what is urine made up of. By the way, the kidney filters every day, both kidneys filter every day 170 decimeter cubic of water or cube, and 1.5 cubic decimeter of urine actually are produced in the same period. So lots of work our kidneys have to do. That's why we should watch what we eat, what we drink. We should drink lots of water, because if you drink lots of water, you can have diluted urine, which is good. But if you don't drink water, you can have concentrated urine. That's why when you work out, you sweat, and most of the water gets out by sweating, then the urination becomes less. That's why you have diluted urine if you don't drink enough water to make it up. That's why we have something which is called homeostasis we are going to talk about, and kidneys play very important role in osmoregulation. Inshallah, by the end of this chapter, we are going to talk about what osmoregulation is. Thank you. All of this is mentioned in your book, page 157, and in the PowerPoint excretion in this page. This is the filtration and this is the reabsorption. Thank you.